8th of May, which is this one here. This one here, this one. Unfortunately, we have not done. I think I released this, but I forgot to tell you that please watch the video and so on. This one, we missed 2 weeks of classes basically. So we missed this, and we missed this. So what I want you to do is to watch the video, watch the video for curve fitting and interpolation. And this one, by the way, these are the material from Dr. Xiao. Last time Dr. Xiao was teaching this subject, but not this semester. So I'm using his material. I'm using his material except for the assignment. For the assignment, I use my own material. So this time I'll be using the same thing. But today's lecture, I will be talking a little bit about curve fitting, a little bit about curve fitting, because we only have 1 hour, 50 minutes. We only have 50 minutes. So please, please watch this video. And this one, and this one too. And this one is from, this is my video, my own video. Okay, but this one is not. This is from Dr. Xiao. Again, I requested, I requested permission from Dr. Xiao to use this material. He said, okay, I can use this material. So this is his material. This is his material. All right, so now, is there any question before we start? Is there any question before we start? Okay, if there is no question, okay, I forgot to do something. I'm going to talk about the basic of regression. Curve fitting has 2 parts. One is interpolation, and the other one is regression. Okay, so let me set up my. Okay. Let me set up my screen here. Okay, let's stop this one. Okay. So I thought I have set this up, but unfortunately I did not set this up yet. Okay. Okay, let's talk about something about that you are familiar with. Okay, let's say you are doing an experiment in your lab. In our lab. Wow, this is really slow. Something is wrong with my PC. All right, so this is excuse me. Something is wrong. Okay, let's start now. Okay, this is the situation now. Okay, let's say you are given a spring. You are given a spring, You are given a spring. So your task is to find the spring constant. So what do you do? What do you do? How can we find the spring constant? You are given a spring. Okay. You are given a spring, and what you want to do is to find the spring constant. Okay, for example, okay, you are given a spring. Okay, spring, and of course, we have a spring constant, yeah, a spring constant. Okay, so we know from physics, okay, the force is linearly correlated to the displacement of the spring by this K, which is the spring constant. Spring constant, and this is the force, and this is the displacement. Okay, the question is, what is the value of spring constant K? So how we can find this? Okay, you're just given a spring, but you do not know what is the spring constant. So what do you do? What do you do? How do you determine the spring constant? Anyone? Anyone? Can somebody say something?
Take the force divided by the displacement.
Okay. So you say basically using algebra, K is just F over X. So how do you do this? So you need to measure the force, right? And you need to measure the displacement, right? That's one way, right? That's one way. So basically what you do is maybe you fix one end of the spring to the wall, okay, and you pull using maybe some equipment that will measure the force, and at the same time, it will also measure the displacement, let's say X, right? That's one way of, this is reading of F. Okay, so that's one way. So is one experiment enough? Is one experiment enough? Is one experiment enough? Do you think, are you sure that that is the correct value of your spring constant? So what do you do normally? You repeat few more times, right? You repeat few more times. So what we can do here is that the simplest way to do this is to, because we know that our F is K times X. So this is just like your line equation, right? Where this is your F and this is your X. And in this case, our force is dependent on our X. Okay, dependent on our X. So, okay, maybe your first experiment, you measure your force and you measure your X. So what you get, maybe at X, or what you can do is you say, okay, if when X is 1, the displacement is 1, what is our F value? You can measure from this reading. So this is one way of doing it. So what you get is maybe this location, where it corresponds to this value of F. So now, when X is at this point, which is maybe this is 1X, this is 2X, then you get it somewhere here. And then one more. Okay, you got it maybe here. And one more, maybe you got it here. Okay, right? So this is the point that you get, right? This is the point that you get. So what can you say about this plot that I just done here, that I showed you here? Is it a straight line? Because if you look at the physics, we know that this is a linear line, right? A linear line, a straight line. A straight line, because x is the power of 1. X is the power of 1. And of course, if you remember your line equation, this is just y equal to mx plus c. And our c is 0 because there's no force when there is no displacement, right? So in this case, c is 0. And if you look at this, we know that our k is just the slope of our straight line. The slope of our straight line. And but unfortunately, if you do this, you can see that it is not a straight line. This is not a straight line. Eh? Maybe it is something that looks like this, right? Why is it not a straight line there? Why is it not a straight line? Any thought? Why the set of points that I just plot is not constructing a straight line? Why? Why do you think it is not a straight line? For example, you know that it might go from here to here, here to here, and here to here. It's not even a straight line, right? So what's the issue here? What's the issue here? And we know that from physics, it should be one linear line. In this case, this is not. This is a 3 segments of straight line. But in physics, from the physics, we know that this is the equation, which is a straight line, which is the blue line, should be a blue line. But it is not. Can anybody tell me why? What was the issue here? Anyone? Anyone?
Because there is error in measurement.
Yes. Remember the first chapter that we learned, the precision and the accuracy? So I think the most famous error in UTM, at least for mechanical student, is what error?
Parallax error.
Itu memang standard saya daripada dulu sampai sekarang. Even 30 years ago when I was teaching. Radat parallax. This is the Malay word. Very famous word. Okay. No, in this case, it's not due to Radat parallax or parallax error, but this is mostly because of your accuracy of your precision of your equipment that you are using. So this is one of the issues lah. So we know that when we do experiments, we are bound to have errors. The precision of the equipment is one of the major issues, major source of error. Okay, that is why instead of using a ruler, why not using a vernier caliper? Okay, vernier caliper, because remember that for ruler it is plus minus 0.5. For caliper, the precision is 0.05, which is smaller, times smaller than ruler. And why not use micrometer if possible, which is 0.005? Then the error is smaller. And remember that when we were talking about error, we know that the true value, true value is equal to approximation plus error. So your measurement, is sort of your approximation, and your precision is your error in this case. So how do we reduce error here? for at least for the equipment, what we need to do is to use a high precision measurement tools. For example, instead of using a ruler, use a vernier caliper. So if you are using a vernier caliper, then the error is 0.05, which is smaller than using a ruler, which is only plus minus 0.5. So this is the idea. This is the idea of doing experiment. Okay, this is the idea of precision and accuracy. Okay, now the issue here, if you look at this, if you look at my plot here, so which one represent the correct value of the curve here, the straight line? Is it the blue line, or is it, let's change color, kita color hijau lah ya. Is it this one, or is it this one? It is still a straight line, but slightly off than the blue one. Or is it the light yellow, light green? Is it here? Okay. Or is it orange here? Is it this? Okay, so let's maybe, is it this one? So let me zoom in here. So which one do you think is the correct one that represent our experiment? Which one? The blue one, the dark green one, the light green one, or the orange one? Which one? Which one? Anyone? Which one? So what's the problem here? What's the problem here? What's the problem here? Anyone? So the problem here is that we do not know which one is the best. I remember when I was doing my experiment, first year experiment. So what we did was, during my time, kita tak ada Excel. So what we do is we just use graph paper, and then we just take a look like this. I say, oh, okay. All right, this is the what we call the best fit for our curve, for our points. So now this is the issue here. Now this is the issue. So how can we determine which is the best line here, or what is the best line, and what is the equation of the line? Okay, because a straight line is just basically y equal to mx plus c. So which one? Is it this one? Is it this one? Is it the black one? Is it the blue one? Or is it the light green one? Okay, so this is the issue here. This is the issue. So we need to find the one with the least error. Again, in numerical method, what we want to do is to have our approximation with the least error. Because when our error is the least, our accuracy is better. Our accuracy is better. So this is the idea here. This is the idea behind what we call regression. So remember, I told you just now, when we learn curve fitting, we have okay, when we learn curve fitting, there are two types of curve fitting. Okay, one is what we call a regression. The other one is what we call interpolation. So you must know which one is which, which one, when to use regression and when to use interpolation. So from my experience, every semester, students will have problem with this. They do not know the difference between regression and interpolation. Okay, they do not know the difference between regression and interpolation. Okay, so now I'm talking about regression. Maybe next class we will be talking about interpolation. We have about 20 minutes here. So regression, regression. So again, back to the issue here. So how do we find the best line that has the least error? Okay, so that our accuracy is better lah. So let's look at this idea here. Let's look at this idea. Remember that our curve here, our curve or our function is y equal to mx plus c, right? Or if you write it in terms of a polynomial, it is just a naught, which is your constant, plus a1 x. If you look at this, this is just another way of writing your line equation, which is y equal to mx plus c. The same thing, but I put it in a generalized form. And of course, this is our true value. This is our true value. And we have some, what we call errors, or what we call E is either error, or what we call a proper term is or residual. Residual is the leftovers, the residual or the leftovers. Note that if E is small, then our model, our line is more accurate. So the idea behind this is to make E as small as possible or minimize. Okay, so from this equation, we know that E is just y minus a naught minus a1 x. Note that, let's say this is again our experiment, and we know from physics this is our line that represent f equal to kx. But in our experiment, what we have here is this point here. This point, our point, this point here. And in this case, this is our error. This is our error. So for 1 point, we have 1 error. So it can either be negative or positive. It can be either negative or positive. Okay, that's one. Or maybe our other point, okay, let's say this is our first point. Maybe our other point is this. And again, this is our error. So at every point, we have our E, our error. So in this case, let's say EI, okay, at point I here. So the coordinate is XI, which is, this is our XI, or maybe X1 here for our first point or in the experiment. And of course, this is our Y1. And of course, now this might be our X2, and this is our Y2. Okay, our Y2. So, of course, this is our YI. So, that is only for 1 point. If we have a lot of points, so we have maybe let's say if you have 10 points, then your I is from 1 until 10. So what we want to do now is to sum everything, to sum all the errors, Okay, so now we have EI, and the sum of every errors for every point is E1 until N, which is just simply this one. Okay, yi minus a naught minus a1 x I. And again, I is from the first point until your last point. So now, look at this. This is basically the sum of the error, sum of the error. Dekat point 1, we have this error. At point 2, we have this error. At point 3, we have this error here and all errors. Remember that, again, this is our true value here, our true value or our model, our physical model. But when we do the experiment, it is not, the points is not falling on the theoretical model. Tak ada. It is away, it is slightly away from the model. And that is the error. So now, again, the idea here is to minimize the error. Minimize the error. So what we want to do is to minimize this. Why are we going to minimize this? The whole idea is, again, to get a better accuracy. Because less error means better accuracy. That's the whole idea here. So how do we do this? How do we do this? Note that this value can either be negative or positive. Yeah? Either negative or positive. In this case, my y is below the line, which means this is smaller than the model, and it will become a negative error. A negative error. The problem with negative error here, we have negative error here, positive error here. It might cancel out. It might cancel out, but yet we cannot get the correct representation of the model because the cancel out effect. So what we want to do is either to use this. We say, okay, why not we take the absolute value, because we do not care about the sign. What we want to know is the magnitude of the error, not the direction of the error. Okay, so we take the absolute value of the error. So because we do not care about the sign, but we do care about the magnitude of the size of the error. So this is again, last night I was teaching my son about the absolute value. I was teaching him what's the meaning of absolute, and he was confused. And I told him that this is similar to, the effect is similar to this one, which is EI, because when we square it, okay, when we square it, we eliminate the sign, because a negative value, when we square a negative value, it becomes a positive value. A positive value, when we square it, is still a positive value. So it has no sign. It has no sign issue here. So the effect is similar to this one. And again, so what we can do here is yi minus a0 minus a1 xi square. Okay, now look at this. What is summation of EI? Summation of EI is what we call the summation of the residual. Okay, the summation of the residual, the sum of the residual. Okay, the sum of the residual. So this is the one, the sum of the residual. And what is this then? What is this then? This is what we call the sum of the square of the residual. Okay, so for this one is what we call sum of the square of the residual, and it is given the notation as SR. SR. R is for residual and S is for the sum. Okay, and this is the definition. This is the definition. So what we can say here is SR is just the summation of E of E I square, which is equal to this one. yi minus a naught minus a1 xi square. So now this is what we want to minimize. So minimize this. Minimize the SR. How do we minimize a function? How do we minimize a function? Okay, so this is the strategy. This is the strategy. So we are trying to minimize the error. Again, this is the basic concept of numerical methods. Minimizing the error. Remember when we do the test, it's always asked how can we minimize the error? Okay, find the error. Of course, with iteration, the more iteration we do, the less error that we get, right? Your error, I think in our test, I just said, okay, repeat only up to 3 iterations. Okay, now what we want to do is to minimize. So what we should do. Now, let's say I have a function here. I have a function, this function. So we know, okay, so we know, let's say start from here and it ends here. So we know that this is our maximum value of the function, right? This is our maximum value of the function. And this is our maximum value of the function. And this is our minimum value of the function. So how do we know that that point is the minimum or the maximum point? How do we know this? How do we know this? How can we prove that this is a maximum point? And how do we prove that this is our minimum point? How do we do that? Can we do something about this? Can we prove it? Mathematically, can we prove it? What's the characteristic there? What's the characteristic there? Anyone? Calculating the amplitude of the wave. Okay. One thing is, note that our slope here at either our maximum point and our minimum point is 0. That's the basic idea. I think you learned this in your high school. Either Form 4 or Form 5. I don't remember. For me, Form 4, Form 5 was about more than 30 years ago. Almost 40 years ago. So the first thing is the required condition is that in this case, let's say this is our y, this is our x, our dy dx must equal to 0. Okay, so now this is dy dx equal to 0 and this is dy dx equal to 0. So how can we differentiate which is the maximum point or the minimum point here? Anyone? That's the first requirement. What's the necessary requirement? The necessary requirement is Mr. E. You answer the question just now. You should be able to answer this one too. Anyone? So what's the other requirement here? Okay, the first requirement is gradient equal to 0 or the slope equal to 0. That's fine. So what's the other requirement? To determine either that point is a maximum or a minimum. Okay, so we can see physically that that the slope is 0, and for a maximum point that we know that the curve is going downward, which is going downward here means a negative, something negative, which is in terms of mathematics, it is just your d square y dx square, or basically if I write this in a different form, so you know that our dy dx is the slope, right? Or the gradient. And what is dx of dy dx? The change of the slope. The change of the slope, right? With respect to x. And normally you see it is written this way, dx square. So basically, this is telling us the rate, the change of slope with respect to x is this one. The change of slope. The slope initially is flat, and when x increases, you see that the slope is this way, and this way. So basically, it should be a negative value when that point is when a point is a maximum. Okay, and the same thing here. Note that at this point the slope is 0, but when we increase our x, it will go up and up. So for a maximum, a minimum, then our change of our slope with respect to x should be a positive value when a point is a minimum point. Okay, so based on this, you know that we need to do this. We need to differentiate this equation here. So how do we minimize our SR? Is just basically what we need to do is to, what's my solution? Okay, so what we need to do is just to differentiate this equation here with respect to, all right, so let's look at this. Let's look at the equation again. Let's look at the equation again. We know that our SR is summation of I equal 1 to n yi minus a naught minus a1 x I, and everything is square. Now to minimize this, the error, the residual, okay, residual. So what we need to do is to do the differentiate SR. But now with respect to what? With respect to what? Note that our xi and our yi is the value that we get when we do the experiment. So basically, xi and yi is a constant value for our experiment. Okay? And whatever that what we have is just another two variable, which is a0 and a1. So we need to differentiate with respect to d a0. Okay? And we also need to differentiate with respect to d a1, because there are two variables here. Two variables, not just one variable, but two variables, a0 and a1. So, okay, how do we do this then? So just differentiate. Oh, I never differentiate anything with the sigma sign here. What is a sigma sign? Basically, sigma sign is just an operator, right? Operator, just like your plus and minus, okay, or division, or subtraction, or multiplication. It's just an operator. To operate your equation. Okay, so let's do this. So now what we have to do is just, so let's say this is just one function. So when we differentiate this, we need to differentiate with respect to a0 here, with this a0. Then this is just 2, the summation of I equal to 1, and yi minus a0 minus a1 minus xi. Okay, the power reduces to 2 minus 1, which is 1. And because of chain rule, we also need to differentiate whatever is inside the bracket. So in this case, with respect to a0 is just differentiate. In this case, differentiate a0 with respect to a0 is just 1. And of course, there's a minus sign here. So minus 1. Minus 1. Okay, now let's do differentiation with respect to a1. So again, with respect to a1, there's a 2 here. So 2 I equal to 1 until n. yi minus a naught minus a1 xi. Now, using chain rule, we need to differentiate whatever is inside with respect to a1. Now, this is a1 times xi. So negative sign will be negative a1x. A1 is, when you differentiate a1 with respect to a1, this is just 1. And this is xi. And of course, everything here should be sum. Should be sum. Okay, now we have two equations and two unknowns, right? We have a naught and a1. So we need to solve for what is a naught and what is a1. Okay, so we have two equations and two unknowns. You can do this using your system of linear algebraic equations. So, but what are all this here? And of course, sorry, this should be equal to 0. It should be equal to 0. This is telling us that the slope at that point is, with respect to a naught, is equal to 0. The slope of that point, which is our minimum point, with respect to a1 is, of course, equal to 0. Okay, this is what we learned from this curve just now. This is what we learned from this curve just now. The gradient must equal to 0. Okay, now let's expand this. Let's expand this. So let's say equation number 1, and this is equation number 2. Let's say from equation number 1, we know that this is just minus 2 summation of I equal to 1 to n yi minus a naught minus a1 xi, and of course let's leave that minus 2 equal to 0, and when, because the thing is equal to 0, then basically this is can cancel out, right? So now what we have here, summation of yi minus summation of a naught minus summation of a1 xi, and should equal to 0. And of course, we are summing from 1, I equal to 1 until n of yi. So this is just yi plus yi plus yi plus yi n times, right? So yi plus yi plus yi plus yi, let's say n times. So this is just n times y. Sorry, there's no more I because we have sum everything. So this is just n y. So this is just our ny. Let me check my solution here. Okay. Something's not right. Okay, so what we have here is just okay, so this is just n y and y and y. This one is a naught plus a naught plus a naught, right? Plus a naught and so on, right? Sorry. Note that I cannot do ny here because y is different value. Y is not a constant. Y is our variable here. Y1 might be different than y2, might be different than y3. So then this is just summation of yi. And this one is a naught plus, sorry, this is wrong. This is wrong. So this might be, the idea here is wrong. So because what we have here is maybe y1 plus y2 plus y3. So y1 is different than y2 and it's different value than y3. Then we cannot just simply do it like that. But for this one, for a naught here, what we have is a naught plus a naught plus a naught plus a naught n times. So this is just, okay, A0 plus A0 plus A0. Note that A0 is a constant, right? A0 is a constant value. So it is just n times A0. N times A0. And this one is, there's nothing we can do. This is still the same thing, A1. But note that since A1 is a constant, what we can do here is we can take A1 out. This is A1 summation of xi, because this is just telling us that A1 x1 plus A1 plus A1 x2 plus A1 x3. So basically what we can do is equal to A1 x1 plus x2 plus x3 and so on, or we can simplify this as A1 summation of xi. Okay, and this is equal to 0. So note that what are our unknowns here? Our unknowns are A1, A0, and A1. So we can rearrange this in such a way that this will become n A0 plus A1 summation of xi equal to summation of yi. So this is the first equation from this one. Okay, now what we can do here is we can work on the other one. We can work on the other one, which is from equation 2. What we have here is again the same thing. This is just 2 will be gone because it is equal to 0. Then what we have here is a summation of, okay, yi minus A0 minus A1 xi times xi times xi, and this one should equal to 0. Note that our minus and our 2 is just a coefficient, right? And because this is 0, then our coefficient, we can set it equal to, it's gone, it's gone. We can cancel it out. So now this is just a summation of xi yi minus A0 xi minus A1 xi square and equal to 0. And again, if we do the summation now, we have summation of xi yi minus A0. A0 is a constant. Summation of xi minus A1 is a constant of xi square, and this should equal to 0. And if we rearrange this, because our A0 and A1 are the unknowns, so this is A1 summation of xi plus A1 summation of xi square, and this should be equal to xi yi. Okay, so these are the two equations. These are the two equations. So can we solve for A0 and A1? Can we solve for A0 and A1? So we are running out of time. So what we can do here is that we can simply write this in the form of SLE, which is our n. Okay, our n summation of xi, summation of xi, and of course these are our unknown, A0 and A1, and this is the value of summation of yi. Okay, and of course the second equation is just this one. This one, this one should be A0. So this is summation of xi, and this is summation of xi square, and this should be summation of xi y I. Can you solve for A0 and A1 using SLE? Of course, remember that n is our number of points, xi is our our x coordinate at the I time, and so on. So this is the set. And can we find A0 and A1? Of course, you know how to solve this, right? Of course, you know how to solve this. Okay, so I'm sorry I took your 10-minute times. So please, Please be aware that I'll be giving you assignments after this. For the topic that we missed last time. Okay, before we go, any question? Before we go, any questions?
No,
Can you speak? I cannot hear you.
no.
No question. Good. Okay, if there's no question, then I think we can stop the class today now. And thank you for joining my class.
Thank you, Doctor.
All right.
Okay, thank you, Doctor.
Thank you, Doctor.